Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. I hope you had a great week. I am definitely very excited today, very happy, and we'll get to that later on. Um, well, from the title of the podcast, you see it's an interview. So I'm very happy. I want to start by thanking you for the support again. Remember, Let's Talk Micro is available in all podcast platforms. Uh, Apple Podcasts, Spotify, Amazon Music, Audible, Overcast, Pandora, wherever you're listening to your podcast, you can find Let's Talk Micro on iHeartRadio. Also, I am on Instagram as Let's Talk Micro, and I am on Twitter as Let's Talk Micro One. So go ahead and follow me. I post pictures of organisms. I post about the episodes that I have, and in this case, if I have interviews, I post about them. So go ahead and follow me, please. On our last episode, I went over oxidase. What is oxidase? So some organisms have an enzyme called cytochrome oxidase, which participates in the electron transport and in the nitrate metabolic pathways of certain bacteria. I'm just recapping like I always do. Getting technical. Very simple test. It comes in a dropper, and you flood the filter paper with it. Then you apply your colony. A positive color is purple, and a negative is no color. So just remember a few things that I talked about in the last episode. When you're observing for a color, you do so for no more than 30 seconds. Any longer than that, and you can have a false positive result. And also keep in mind that some organisms, they can have a weak positive reactions. So for these organisms, it is best to use a swab. And I like to talk about Pasteurella. So for Pasteurella, the oxidase works better with a swab. You can try the filter paper, and you might not be able to see a reaction. Sometimes if you do see one, you can barely see it. It is almost as if you're almost imagining it. So when you have organisms with these, especially if you have a Pasteurella, I mentioned, so you do it on the filter paper, you have difficulty seeing it, go ahead and do it on the swab, and then you definitely will be able to see it better. So it's a good technique to use before you actually document that something is oxidase negative. And especially if you know that the result should be positive, by doing it with the swab, you can make sure, and it will be noticeable. So within those 30 seconds, you'll be able to see a color if the organism is positive for oxidase. Also keep in mind that when you are choosing your colonies, and to get your colonies, you either with a stick, right? You touch your colonies, you put the stick on the filter paper. If you're using the swab, you swab your colonies. So when you're choosing your colonies, and I'm talking about agar, use the blood agar primarily. And then if chocolate, if you don't have blood agar. So for example, if you're dealing with a Haemophilus that does not grow on blood agar, then go ahead and use the chocolate. But do not use McConkey, since this has a color and already, McConkey is pink. So you can interfere with the colors, and you can have a false reaction. So use your blood agar primarily, and if it's not growing on blood agar, then go ahead and use your chocolate. And then we went over some groups and their reactions. We talked about the non-fermenting gram-negative rods, which can have varied reactions, right? Pseudomonas positive, Burkholderia positive, Acinetobacter, Pseudomonas negative. And we definitely touch on diseases that these organisms can be implicated on, and where do you see them, like hospital environments. We also talked about the fastidious gram-negative rods, which are positive, the ones that I talked about. And then we talked about the Enterobacteriaceae or Enterobacteriales. So what about them? You remember? They are all oxidase negative, no variability. Unlike the indole, where you saw, right, like E. coli is positive, Proteus mirabilis negative, Kleb pneumo negative. So you can have some members with an indole positive result, and then you can have some members with a negative indole result. So with the oxidase on the Enterobacterialis, there is no variability. So please keep that in mind. Enterobacteriaceae or Enterobacterialis are all oxidase negative. So if you have an oxidase positive organism, it is not an Enterobacteriale. Okay? So please keep that in mind. So like I mentioned before, indole oxidase, two widely used tests for gram-negative rods, and you can use them for gram-negative cocci as well, which I will talk about at a later episode. But very helpful. So we talked about some organisms. Most organisms, they tend to be positive for one and negative for the other, meaning one can be indole positive, oxidase negative, like the Enterobacterialis. You can have oxidase positive, indole negative, like Pseudomonas aeruginosa. And then you can have organisms that are actually positive for both. Indole positive, oxidase negative, like Aeromonas, Pastorella. So just keep that in mind. The only thing is that those can be positive for both, but if you have an E. coli, if you have a Klebsiella oxytocca, a Proteus vulgaris, these are indole positive, but they're oxidase negative, just like all the members of that group. And I like to say that because it's important. That's one of their trademarks of the Enterobacterialis. They're all oxidase negative. So I like to repeat it as a reinforcing tool. So going back to what I said at the beginning of the episode, I am very happy today because I want to start having microbiologists in this podcast so they can share their experiences. They can tell their stories. There's variability on how we identify an organism, what kind of media do we use, how does it get worked up, what guidelines are used. Also, you get different parts of the world, you have organisms that are more prevalent than others. So this is very exciting. And as you are listening to this, I hope that we continue bringing on more microbiologists to share their stories. Use this as a forum to share with the rest of the world what you do. So as part of our podcast, I've been telling you that I want to start doing interviews, and the moment has finally come. I'm so happy and excited. Today we have our first interview. She's an environmental microbiologist all the way from Mexico. Her name is Karla, and here she is. Hi, Karla. How are you?
Hi, Luis. Very fine. Thanks for inviting me to your podcast.
Well, you're welcome. Thank you for doing this. You are our very first guest.
Yes, I have the privilege. Thank you so much.
All right, thank you. Okay, so let's start by tell the listeners a little bit about yourself.
Okay. Yeah, well, I'm from Querétaro. I'm a microbiologist. I studied the microbiology degree in the Autonomous University of Querétaro. My career lasts 4.5 years. And yeah, nowadays I'm working in a food microbiology laboratory. And yeah, I really love my job. I work with microorganisms all days, and yeah, I do that.
Okay, yeah, definitely sounds good. We definitely like I told you before, my approach to it is clinical, so it's always nice to talk to someone that does, deals with the organisms, but is doing it in a different way with a different impact. Like for us, it's all about the patient, right? Make sure the patient is better, find the organism, do susceptibilities, so the patient can get the proper treatment. And then, and also, I mean, we report some organisms to the state just to make sure that there are not outbreaks. But it's definitely
Yes.
interesting because you always hear, like, you're sitting watching the news, and then they say, oh, there has been a recall because there's an outbreak of salmonella. Um, like, don't eat the peanut butter because it has salmonella. Some
Yes.
contaminated eggs, E. coli in hamburgers. So they start sending like the numbers of, if you have this product, go ahead and return it. But us as clinical microbiologists, that's the end of it. So then, but on your end, you're dealing with this, companies to make sure that their product doesn't have the organism to prevent these outbreaks. So tell us more about an environmental microbiologist. What do
Yes.
you do? And I know you mentioned your education. So is that what you need to do to go to school to become one?
Yes, yes. Of course, you have to study something like a microbiology or something near of that, because we have to work with microorganisms all day. And yes, what we do is to receive different kind of, for example, swabs, food, waters, and everything that a food company has inside the company production. So we have found different kind of microorganisms inside the food. For example, we work a lot we deal with salmonella, for example, is the most common microorganism that we find, but also E. coli, also listeria, um, different kind of quantification, for example, of more general bacteria like mesophilic bacteria. And we count, for example, molds and yeast, and also coliforms is the most common microorganisms that we find. Um, yeah, we also work with different kind of techniques inside the lab. We have the traditional part that it's ruled by norms that are in the country, but also we work with molecular techniques like PCR is also the most common technique, and yeah, we do that.
Awesome. Okay, so as I've been, I mean, I with the listeners, I touched a little bit about gram stains, about media. And for those of you that maybe are just tuning in, so normally in the clinical sector, we deal with samples from anywhere from blood, swabs from any area of the body, uh, any body fluids like pleural, pericardial, synovial. So they arrive in the lab, and then we put them in media. And I talked about media in an episode.
Yes.
So our basic standard setup, depending on the cultures, basically if it's an urine, you get a blood and a McConkey. If it's anything else, your basic, it's like blood, chocolate and McConkey, and anaerobes if they're depending on the source, if they ordered them, like any anaerobic media like CDC, Shaler's, and a gram stain. So in your case, when you get a sample, where do you start? What kind of media do you use?
Yeah. Well, always we have to put a sample in an enrichment media. For example, it also depends of the microorganism that a custom are soliciting. So, for example, for Listeria, we have to make the primary enrichment with freezer broth, for example. But for example, for Salmonella or E. coli, we used to use Pepton water. Also, for a technique that it's very traditional, there is more probably number, we use lauryl sulfate broth. We can use it in a simple or double concentration. It depends if it's a food or it's a water. If it's a water, we have to use a double concentration. But if it's a food or a swab, we use a simple concentration of lauryl sulfate broth. For example, in some cases, we also use lactose broth. And if is Staphylococcus aureus, we use Very Parker agar direct. But the other is the primary enrichment. Then we have to make a culture with a secondary, a secondary culture, or something that is new also in Spanish, like resiembra or reseeding. In this part, we have to take little of this liquid that has a lot of bacteria posterior the incubation time. And we use, for example, for Listeria, Oxford and Palcam, for E. coli, EMB, and we have another one like for Salmonella, XLD, or bismuth sulfide.
Karla? Yeah, sorry to interrupt. So you said for E. coli, EMB?
Yes.
Oh, nice. I remember EMB from school. Beautiful color with E. coli.
Yes, it's my favorite one.
Well, that is cool. I remember, when I, like years ago, when I was doing the medical lab technician, like we use it. But after once I did the medical laboratory sciences program, I haven't seen it in hospitals here. But you still see it, and definitely in other parts of the world, all types of labs, they still deal with it. So that's definitely eosine methylene blue.
Yes, eosine methylene blue. Yes, exactly. Is a yes, is the meaning of EMV. Yes, it's beautiful media. I love it. The reaction that green colonies are awesome. Yes, for E. coli, it could be one colony with the black center or that characteristic metallic grain in the surface. But you can discard immediately E. coli if you have pink colonies in the agar. Yes.
Okay, good. And so then you were saying for Salmonella, what do you use?
Yes, for Salmonella we use XLD, bismuth sulfide, and enteric bihentoin. Yes, is what we call that selective media. We use that that kind of agars in the secondary enrichment. And then if you have the characteristic colonies that are Salmonella, well, we use to compare the the colonies with TCC controls. So if we have the same colonies, we have to make a pass to soya tryptase, that it's a general media, just to recover that colonies and to have a young culture. And then if you have the young culture, we use TSI or LIA, That's to see the lysine descarboxylation and I don't remember the word, but metabolism of iron. Yes, iron metabolism.
And for LIA?
For LIA it's the lysine descarboxylation. Yeah, we have to see how the media turns more acid or more alkaline, and we compare with the control. So in that part of the process, if we have that biochemical part, sure, we make the last part, that is to improve the result with a Vitek. Yeah, that is more specific, and you have the name and the genus and the species of that, well, with a percentage. We sometimes, I'm not totally sure of that result. We have to make a decision, but you have the other part, that is the biochemical part, so you can yes, we can share that criteria and tell to the customer a result.
Yes, and definitely, you were mentioned that the TSI, which is the triple sugar iron, and it's funny, like you're mentioning this, and I was this week working on an episode for that, so I'll be talking a little bit about that to the listeners later. So it's definitely a test that, especially as a microbiology student, you definitely need to know. We use it, I mean, here in the States, you definitely get asked about it when you're doing your board certifications. So definitely might not be used as quite in the lab, but it's definitely something that you need to understand how it works.
Yes, of course. Usually, for example, one of the ATCC controls, that is Salmonella typhimurium, you have to be sure that it's Salmonella, because in that media also produce the ácido sulfídrico, sorry.
Yeah, hydrogen sulfide, yeah, H2S.
Yes. Yes, H2S. So it's basically, if you see that, you have to say yes, this is Salmonella typhimurium, but we have also the atypical salmonellas that don't make that reaction. So it's a little more difficult to make the result with that or other ones.
Okay. So definitely, yes, those ATCC organisms were widely used in the microbiology community to do your weekly QC, depending on what they're definitely, a part of our work in the microbiology setting. And before I move on, I know that you mentioned that's a term that, you said the like when you use the siembra, right? So that's you're plating the organism. That's definitely a word that I heard a lot, and I told you, I mean, like I'm from Puerto Rico, but like I went to school in the States, so a lot of my microbiology terms are always in English. But I definitely work with text. I went to school in Puerto Rico, and definitely, sembrar is a word that I hear a lot. Yeah.
Yes. It's very common here.
Yeah, it's like, like sembraste esto, or so definitely, I'm familiar with that. So for all the listeners out there, it is when you're plating the organism. I want to touch back on you were talking about the concentration. So maybe can you talk a little bit more about, you said with the water samples, you use a double concentration?
Yes. For example, with one methodology that we work a lot here in Mexico, that is a more probably number. We have to use the double concentration of the lauryl sulfate broth, because, well, the theory says that it's more probably to recuperate a microorganism with this concentration, because also the sample is ubiquitous, and maybe you don't have a lot of microorganisms instead of food. For example, in food you have different kind of sugars or proteins or more nutrients that the microorganism can take. So that's why we use the simple concentration just for food, for example, or swabs. And then it's a more probably because we change the concentration. And it works differently in food than water. For example, in water, we have 10 tubes for sample, and we put 10 milliliters of the sample in each tube. But in the case of the food or the swabs or the sponges, we have the simple lauryl sulfate broth. We have 9 tubes, and we have to divide these 9 tubes in 3. So the first 3 tubes has the direct concentration or the first dilution. Then the second, the other 3, you have to make another dilution and then another dilution. So you can see, for example, in the growth in 1 and 2 and 3 and 4 and 5, anything. And yeah, you have to make a pass of these positive tubes, and then the result is based on that positive tubes. So it's just a game of probability, and it's a very traditional technique that we use here, or that is very used in food microbiology industry.
Okay. What about gram stains?
Gram stains, yeah, I really love gram stains. But here in this lab is something that it's a secondary process. Yeah, we have to make this first primary enrichment, then the secondary enrichment. We have to say, okay, I'm very, very sure that is this colony, typical colony of this microorganism. I'm sure because also I make the biochemical part, and then we make the gram stain. We make the gram stain before to use the Vitek or the MDS or the PAX or molecular comparison. Yeah, it's a secondary process that we make. Yeah, but yes, we also use the gram stain. It's a very basic technique in a microbiology lab, and we'll pass the years and in all the world we we will use this technique because it's awesome.
Okay, very good. I just want to touch on, so when you get these products normally or from the companies, are they asking you to look for something specifically or to see if there's something in there growing, like to rule out the presence of any organisms?
Okay. Yes. Well, the company tell us what they want. For example, maybe if it's just a water, yeah, it's a water of I don't know, something that is not very important in the process. Maybe they only tell you that they need, for example, more probably number. But if it's something very special in the process, or is the final product, for example, I don't know, a lettuce that will be in the market, yeah, they will tell you that need E. coli, Listeria, Salmonella, more probably number, mesophilic aerobic bacteria, molds and yeast. And yes, it's basically everything. Also, they can tell you, well, we want to know if we have Listeria in this product, but we want to know the result by norm, by PAX, by MDS, or different techniques, because they want to be very sure that they don't have that microorganism inside the product.
Okay, yeah, and that's great. I mean, and definitely very responsible of the companies, because yeah, that's the outcome of having an outbreak. It's serious. I mean, the most important thing is that, of course, our patients, us as a population, we can get sick. Sometimes, it can result in death. So very serious outcomes. And then, of course, the second outcome, and to a lesser extent, of course, the financial of having to retire that product. But of course, our main one is always our patients. That's what You do your work. That's what I do my work. It's always about
Yes,
finding what there is so we can either treat it, or in your case, preventing it from going out there to us, the consumers.
exactly.
So that's pretty good. It's
Yes.
very responsible of the companies doing that. Um, that's great. And yes, okay, so I guess yeah, so your gram stains are used to a lesser extent than we do here. I mean, we gram stain all day here in the clinical side.
Yes, you told me that is something that you make in the first part of your process, no?
Yes.
Isn't it?
So you're the first part of the process, and then also, of course, when you are on the organism has been plated already, and then we're not sure. Um, so we always do a gram stain just to make sure that what we see. And I like to repeat this over and over because you'll be surprised, like you hear me say it in the podcast. I tell it to students, and it keeps happening. Like people just do not want to do gram stains sometimes, and it is so helpful. Case in point, before the interview, we were talking about the MALDI-TOF and how sometimes it has that it's leaning a little bit towards doing less work. It's like, why do all this test when the instrument will tell me what it is? Well, our
Yes.
MALDI-TOF, of course, with the COVID pandemic, supplies tend to run short. So one of the issues that we had was that we have no tips for the MALDI-TOF, and I'll do an episode about the MALDI-TOF. So we had to go back to the old school methods, doing the biochemicals and everything. And some techs did get in trouble because they were calling things coagulase negative staph just because they saw them on blood agar, they were white, but it turned out to be a gram positive run. And it turned out to be a yeast. When all you had to do was put it on a slide, do a quick gram stain. Oh, it's not a gram positive cocci. It's probably skin flora. I'm done. So now you get written up, you get in trouble. But more importantly, you put false results out there, which can potentially harm the patient. So I always recommend, gram stain is great. In large facilities like the one that I work with, it's definitely, you can spend 8 hours doing gram stains, but hey, it's part of our job.
Yes, but it's part of the job, and I really love that what you said, that it's the old school, because yes, technology it's amazing. You can have a result immediately, but you have to know the the background of every technique, and old school is
Yes,
awesome.
old school definitely is. And like I told you, and I'm telling the listeners out there, basically a good thing is when you are, by the time that your organism it's going to the instrument for a formal ID, you should already know what it is, basically. I mean, yes, of course, sometimes it can be a degree of variability, but based on your biochemicals, on your morphology, on what you're seeing, on your SARS, you should already be knowing what it is, have an idea. And of course, if a new technologist is listening out there, or a brand new microbiologist, you're doing, well, they look so different. Believe me, it gets easier with repetition. It gets easier with practice. You'll get to that point where you can tell, oh, maybe it looks like I have a Stenotrophomonas here, or I have an Acinetobacter, or I have this type of Enterobacteriaceae, or what they're called now, Enterobacteriales. So yeah, on the clinical side, so we have plated our sample, we have done our biochemicals. So now it's ready to formally ID the instrument. And I know that we talked about this. So for example, like in the labs that I work with, it has been mostly Vitek to do the final identification, or we use the MALDI-TOF. Some organisms you can actually, based on certain characteristics, you can ID them. Like I like to mention like Staph aureus, it's beta hemolytic, catalase positive, coagulase positive. You can call it Staph aureus without putting it on an instrument. So for your work, what do you use to do formal ID? Like, how do you get to officially putting on paper saying we have a listeria, we have a salmonella, we have an E. coli?
Yes, we mostly use also the VIDIC. I think that VIDIC is a universal instrument that we used in all microbiology laboratories. But also we have something that is known like MDAs. This is basically a PCR by lamp. What we do is to heat rotate pills that, yes, that have all the elements inside, like polymerase, like DNTPs, or yes, everything that you need for a PCR, but it's everything inside a pill. So we just have to heat rotate that and then to see the PCR in real time. Also, we have another PCR real time that is known like BACS. It's the same heat rotate pills, and we have to see the fluorescence in the curve, the melting curve have to be the same like the ATCC control. And we have something a little different that we also make collaborations with that is known like VIDAS. This instrument works with antibodies in inside of a inside of um, how do you say punta, like a very long punta. Yes, I think I have the name. Just let me a second.
Yeah, no problem.
Yes, like live cone. Live cone. Yes.
It's not a tip. Punta is tip, but no.
It's like a punta, but it's the correct name. It's a cone. We have
Cone.
yes, we have to take with very delicate yes touch that cone, because in that cone we have all the antibodies that will react with the antigen of the bacteria. So this method is very interesting also.
Yeah, as you were saying that about the, like, I mean, if the word comes back, I'll mention it after the interview on the podcast. But I'm visualizing what you're seeing. Yeah, so I'll think about it, and then I'll go back to that one. Okay, so and then as far as in your case, you don't do any susceptibilities. I mean, or do you?
You mean like something with antibiotics or something like that?
Yes.
Yeah, no, we don't make anything with antibiotics, but we have some controls that are antibiotic resistance, like E. coli resistant, or yes, basically, I think we have just E. coli, but it's more like a control inside the lab.
Oh, like your ATCC?
Yes.
Yes. And then for all of you microbiologists out there, so yes, as part of the your ATCC organisms, like for example, there comes like a Staph aureus that's oxacillin susceptible. You get a strain that's MRSA but still resistant. So with E. coli, you get your susceptible E. coli. You can have one that's ESBL or extended spectrum beta lactamase. There are strains of Klebsiella pneumoniae that are carbapenem resistant, or your KPC. So yeah, so as far as in your job, all you identify the organism, you let the company know what's there, and then they take appropriate action. But as far as susceptibilities, there's nothing else you do. You just let them know, yeah, this product has a listeria, E. coli, salmonella, and that's it.
Yes, we only have the permission to say to the customer or the company, yeah, we find this microorganism and they have to take the correct actions in the company, but we can't obligate a customer to make something. And yeah, the only thing we can do is to tell the company what we find.
Yeah, it's kind of like us. I mean, we tell the doctor, hey, we have this we have this E. coli with this susceptibility pattern, and then at that point in time, it's up to the physician, the provider, to treat the patient. I mean, we don't do that. So in your cases, hey, I have a, just for argument's sake, so you have a listeria, or this product has listeria. Now they know, so it's up to them to take the appropriate action.
Yes, exactly. Yes, yes, yes.
Yeah, we are messengers, but play an important role, because definitely without our work, people will get sick by consuming a product that's contaminated. The same thing, the doctor wouldn't know how to treat this particular wound because of what we do. So it's definitely a very important job.
Yes, I'm sure of that.
Yeah. So as far as listeria, let's talk a little bit about listeria. Um, so definitely a very significant gram-positive run that we have
Yes.
in the lab. For on our clinical side, it's beta hemolytic, short gram-positive rods. They grow in blood, they grow in chocolate. They have what they call it has a tumbling umbrella motility.
Yes.
But if you put it on that agar, you can see that nice umbrella shape on the
Yes.
motility agar. So for us, very significant. We definitely see it when it can pass from the mother to the baby, and that's when we see it. Unfortunately, in our clinical setting, we have a baby that gets a blood culture, becomes positive in less than 24 hours of a newborn, and then we see the short broths. And as part of our protocol, we have to rule out listeria. So I know you mentioned two types of agar that you use in your lab, which in the clinical side, at least in the labs that I've been on, we don't use it. So there are Qualcomm and Oxford. So tell the listeners a little bit more about that agar and listeria.
Yes, of course. Well, after the first enrichment of Fraser broth, we have to cultivate the presumptive listeria in Oxford and Qualcomm. Specifically in these cultures, we can see very typical colonies that in Oxford they grow like um, with a center black and very big yes, a very big sorry, very big shadow black also. And in Palcam the colonies are are green, but it's a very soft green, and the center is also sorry, sunken. So we can see these typical colonies in the Oxford and Palcam, and then we have to corroborate with biochemical techniques that it's listeria. What we use is also catalase, mobility, but we have other two tests that are carbohydrates. We can see the metabolism of Listeria monocytogenes with Hilose. And for example, another kind of listerias use the rhamnose. So you can make that very big difference between if it's a Listeria monocytogenes or not, because you can see the carbohydrate metabolism. And also we use something that is known like CAMP test. We use that both to corroborate biochemically that is Listeria, because there are another microorganisms that also use the esculin with the ferric citrate that reacts and generates that inorganic salts that turns the black media. So it could be a little confused if it's a Listeria or not, because you can see the black media and say, maybe it's Listeria, but not. If you have for example, negative catalase, you can say, well, not, or the other ones that I tell you. Yeah.
And always that's where a gram stain also it's helpful too. I mean, you said catalase, right? So or is it just like I'm not too familiar with this agar, but uh, does it grow like it's a selective, or can it have cocci rods growing in it?
Oh, yes. Oxford and Palcam both are selective media because actually these media have some antibiotics that can't permit the growth of gram-negative bacteria and another gram-positive bacteria. They are very selective, and it's very complicated to have a contamination in this media.
Is it so? It's unlikely. I mean, or can other organisms? And I guess I'm gonna explain myself. Like, do you know, like for example, like in our case, we use PAR, which is supposed to be selective for gram-positive organisms, but yet Pseudomonas likes to grow in it. So do you get those instances with something that shouldn't be growing and the blade will grow, or is it always just your gram-positive rods?
Mm, yes, we have sometimes another one positive bacteria, but it's a little strange because our stains are resistance of these microorganisms. Sorry for these antibiotics. So sometimes we have a contamination for staphylococcus and enterococci, for example. But because this micro, for example, there is a staph, but you can see that the media turns yellow. So you can say, no, okay, this is not, because we have to see the media black. Okay, it's a contamination. But in the case of enterococcus, we can see the black media. So in this case, yes, it could be a little difficult because the colony could be small. Also, if you see a colony very big, you can discard that media. You can discard that bacteria because Listeria is a very small colony. So you can see that you can be sure that it's Listeria if you see this honked colony, and if you see the black shadow. In the case of Palham, it should be a little green, olive green, very tiny green. And yeah, it's very something that you have to see. But yes, it's very beautiful Listeria. It's one of my favorites one.
Yes, and so one of mine as well. I think it's just I told you, because it kind of like looks like gram-positive, like group B strep, but then obviously it's not, and it's calyx positive, and it's a gram-positive rod. So I don't know, some morphologies of some organisms, they're just, this is, of course, it's a serious organism, but I like the way it looks on a plate. Just like the micro nerd thing that I have.
My
Mhm.
goodness.
So that media, do you incubate it like in a CO2 environment or a non-CO2?
Sorry, can you repeat the question? Sorry.
Yes. So like how we incubate some plates, we put them on a non-carbon dioxide incubator versus carbon dioxide incubator.
Yes. No, we well, Listeria can grow without dioxin carbon. So what we do in the laboratory, and it's very interesting for this microorganism, it's that we incubate Listeria in two different equipment. We have one incubator that is 30 grades Celsius grades. We have another that is in 36 grades or degrees. So this is because Listeria can make different growth depending of the temperature. And this is because this bacteria specifically has some genes that are regulated by temperature. So for example, the flagella in Listeria is regulated by temperature. if you grow Listeria at 30 grades, you can see this typically mobility. But sometimes if you have a very big temperature or higher temperature, well, Listeria will not develop that flagella, that typical flagella, because we have some there regulators in that genus that yes, it's regulated by temperature. It's very interesting.
Yes, Listeria is definitely very interesting, and it likes the cold, so that's why you can see it in those cold cuts sometimes. Like cheese and stuff like that, like in the type of food items. Um, just out of curiosity, so obviously, so you streak your plates. Do you do the 4 quadrants or 3 quadrants?
Yeah, it depends of the technical. Yeah, some prefer 3 quarters, another 4 quarters. In my case, I prefer 4 quarters to have very better isolation of the bacteria.
Okay, yeah, I definitely like 4 quadrants. I mean, I definitely see a lot of technologies that only use 3, so there's that variation there. So you were telling, so in your case, so you quantitate the when you give your final report, do you specify the amount of, let's say, Listeria salmonella that you have, or like do you quantitate it, or you just say, Listeria, and that's it?
Yes, for example, for pathogens like Listeria, like coli, like Salmonella, another one we have to say just presence or absence, or it is or not. But in the case of, for example, molds and yeast, aerobic mesophilic bacteria, we have to say, we have, I don't know, like 20 units for growth colonies, like UFC. And we have to report quantification to the custom, but just with this with these cultures that you have to count. But in the case of pathogens, or for example, Listeria, we can say just presence or absence, and that's it.
Okay, so that's in a way similar to what we do. I mean, some like we do, and I told you this, that we quantitate on our urines. When it comes to the 4 quadrant streak, we use 1+2+3+, or rare, few, heavy, depending on the lab that you're on. And yes, we also use some things like when we do MRSA cultures, and that's using the chromager or the vancomycin resistant enterococcus. We say if it's there or if it's not there. Okay, so it's very interesting to see the similarities and on what we do and what you do out there.
Yes, it's very interesting also what you do.
Yes. So is there anything else that you want to talk to the listeners about?
Well, I think we say the most important things that we make in this laboratory. Yeah. So yes, maybe the food that are most contaminated. we we mostly find the sausages, the cheese, and some vegetables like lettuce. In lettuce is where we find sometimes the more quantity of microorganisms. Yes, the company has to make a lot of changes, and we can see how maybe in one time we don't find that microorganisms, and then 6 or 8 months later we also find we find again the microorganism. So it's sometimes in companies or food companies is something repetitive, the problem that they have with a specific microorganism, and that's interesting.
Yeah, right. It definitely is. Yeah, I mean, I'm sure it has to do with, since lettuce needs to be irrigated. I mean, depending on the quality of the water that you use, and um, as you know, like a lot of these organisms, they are in the water. So definitely, if the water system is not completely clean, definitely there can be contamination. So it makes sense. Yeah, well, sausages, huh? Yeah.
Yes, we have a lot of listerias and sausages. It's incredible.
Wow.
Yeah.
Yeah, it makes you think, right, about what you eat and knowing that what's out there.
Yeah, something that has very interesting also listeria is that this bacteria can be growth in cold temperature. So it's something that other microorganisms can't do. So you can think, well, in my food is in refrigeration, I can't have a problem with this, but no, listeria can grow. So it's something interesting with this bacteria, the mechanism that she has.
Okay, yeah. Yeah, definitely likes the cold, and that's why sometimes, especially when you they say that, when you have this, like, you go on picnics and you bring these products like cheese and stuff like that. Um, that's why people can get sick with it.
Yes, and listeria. I think that listeria, particularly, it's the most harmful bacteria that we work inside the lab. Yes, because well, I know that this bacteria can also go to the brain. How you said the placenta can go through there. So the mechanism that this bacteria has in terms of how is the mobility inside the lab, is inside the body, sorry, it's also very interesting how this bacteria can manipulate the microtubules inside the cell. So she can go wherever she wants, not just the stomach.
Yes, it's definitely listeria is implicated, and like the obvious, like, from food, and you from pass to the mother to the fetus, but you definitely see it in, yeah, in bacteremia, and like you said, CNS or central nervous system infections. So it's definitely a very serious organism. It definitely is. And
Yes.
then with all these organisms that you get in the food, it's definitely, you see in the lab, at least from my side, in the trend, as the weather gets better and people start doing outside activities. I mean, now with COVID, it's less, of course, but on other years, you will definitely see, like in the summer months, you definitely had all this samples positive for salmonella, and as people started going outside doing picnics, and you get some contaminated product, and there you have it. So yes, and definitely it's, so you get prepared mentally that, hey, summer is going to be busy with this, especially on depending on which lab you work on. Like I said, this is an organism that you have to report to the state. So some facilities do it where it automatically gets reported, versus maybe in a smaller lab you have to manually do it, and it can be very time consuming. But of course, it's part of our job, and we do this for the patient, so we just deal with it. Okay, Karla, thank you. And like we were talking about, like you said, from Mexico. So I told you it was by coincidence. Like I had planned a trip to Mexico, and then I ended up doing this interview with you. And at some point in time, yeah, I did stop by Querétaro. Um, but I just want to touch on this. Sometimes, there can be some misconceptions about, like, people might say from the outside, hey, maybe it might get dangerous, or be careful. I have to say that I had a great experience. Um, your country is very organized when it comes to COVID. That was very nice. Wherever I went, someone squirted some sanitizer on your hand. They checked your temperature. So it was a beautiful, organized process. So from that part, I feel very safe. Very amazing landscape. The food was great. So yeah, I definitely had a great time visiting your country. Yes.
Yeah. Thank you. I'm happy to hear that. And well, here you're welcome wherever you want. You have to know it. I'm so happy to know people who share the same passion as me. So thank you for this invitation, and thank you for everything. Yeah, it
All
was
right,
a
thank
pleasure
you.
to talk with you.
You too. All right, so take care.
Yes, you too.
Well, there you have it. What a great interview with Karla Zamora from Mexico, an environmental microbiologist. So, very important work, just as we our work in clinical microbiology is to make sure that the patient gets properly treated. In her work, you make sure that you identify if there are organisms in these products, because if there are, they can be harmful to us as consumers. So it's great work, and such a great interview. We talked about more media. I mean, I don't know, here in the States as a clinical microbiologist if you're familiar with them, uh, Qualcomm and Oxford. And then we also talked about EMB, and I will touch up more about this media on our next episode. But once again, what a great interview. And that, my dear audience, it's the end of this episode. I hope you enjoyed this interview, because I certainly did. It was amazing connecting with a fellow microbiologist, and I want to continue doing that. So if you listeners out there want to tell your story about what you do in the microbiology world, please go ahead and reach. I love to teach, I love to connect, I love to talk micro. So please, stay motivated, continue bringing your passion into what you do. It's so important. And definitely continue talking micro. I hope you have a great week, and until next time.